Now, in this lecture, we will find the value of 2 times AP, or the size of 2 times AP. Okay? The value of 2 times AP. Okay? Actually, we have triangle ABC in the picture with side AB that equals to 90 units, side AC of triangle ABC equals to 70 units, and side CB of triangle ABC equals to 50 units. This is given us in the question, and we want to find the value of 2 times AP. Okay, here we have actually also a circle, and the center of this circle is point P, and actually we have 2 tangents to this circle. The first tangent to this circle is side AC of the triangle ABC is tangent to this circle at point, let's call to the point, this point, point O. So the touching point between side AC of the triangle and the circle is called point O, or side AC is tangent to the circle at point O. Okay, and also according to the question, side CB is also tangent to this circle at point, we will call this point point E. So actually the touching point between side CB of the triangle and the circle is called point E, or side CB is tangent to the circle at point E. Okay? The first thing that we will do actually is we will connect points P and O together by a straight line. So PO, as you can see from the picture, will be the radius of this circle. We can call this line OP R, abbreviation for radius, because it starts from point P, that is the center of the circle, and it ends at point O on the circle. For that reason, line OP is defined as the radius of this circle. Okay, we will do the same thing. Actually, we will connect by a straight line points P and E together. And for the same reason, PE is defined as the radius of the circle. We will call it R. Again, because PE starts from point P, line P starts from point P, the center of the circle, and it ends on point E on the circle. So this is actually the radius of the circle. This is how you define a radius of circle. Okay, so we actually draw two radiuses of this circle. Okay, now actually we have a rule that states that in any circle the radius and the tangent to that radius are perpendicular to each other. I will write it down. Okay, according to rule number 1, rule number 1 states that in any circle a radius and a tangent to that radius are perpendicular to each other. Okay, so actually if you have a radius let's call it R, and a tangent to that radius, let's call it T, then the radius and the tangent are perpendicular to each other. That is to say, this angle is 90 degrees and also this angle is 90 degrees. Okay, I'll read it again. According rule number 1 states that in any circle a radius and the tangent to that radius are perpendicular to each other. Okay, so if we have a radius and the tangent to this radius, then they create together in the touching point 90 degrees. So this angle is 90 degrees and this angle is also 90 degrees. Okay, so according to rule number 1, we can say that angle POA equals to 90 degrees. And for the same reason also angle POC will be equal also to 90 degrees. because the radius and the tangent to that radius are perpendicular. So they create in the touching point 90 degrees. So this angle is 90 degrees and this angle is also 90 degrees. And the same rule, of course, applies to this radius. So in the touching point, that is to say point E, in the touching point between the radius and the tangent to that radius, we have actually angle that equals to 90 degrees. So angle PEC equals to 90 degrees, and also angle PEB will be equal to 90 degrees. Again, in any circle, a radius and the tangent to that radius are perpendicular to each other. This is rule number 1. Okay? So, as you can see from the picture, triangle AOP is a right triangle because this angle equals to 90 degrees, and also triangle BEP is right triangle because one of its angles, that is to say angle PEP, equals to 90 degrees. So those both those triangles are right triangles. Triangle APO and triangle PEB both are right triangles. Okay, so in the next step we will draw perpendicular from point C to side AB of the triangle. Okay, we create a perpendicular from point C to side AB of the triangle. So angle C, and we will call the touching point between the perpendicular and side AB of the triangle, we will call it capital M. So angle CMB will be equal to 90 degrees, and also angle CMA will be equal to 90 degrees because of the fact that CM is perpendicular to AB. That is what we did. We did perpendicular, that is called CM to AB. For that reason, CMB equals to 90 degrees, and also CMA equals to 90 degrees. Okay, so as you can see here, triangle CMB will be also a right triangle, and also triangle CMA will be a right triangle. Okay, in the next step, we will define angle PAC as alpha, or angle PAC equals to alpha, and angle ABC will be equal to beta. That is according to our definition. Okay, angle ABC of triangle ABC equals to beta, and angle CAB of triangle ABC equals to alpha. Okay, so I will write it down. According to our definition, angle BAC is defined as alpha, and angle ABC is defined as beta. Okay? Now let's focus on two triangles in this side. Let's focus on triangle AOP. Triangle AOP. That is, of course, a right triangle because angle AOP equals to 90 degrees. And also let's focus on the right triangle ACM. And actually also triangle ACM is also a right triangle because angle CMA equals to 90 degrees. So actually both triangle AOP and triangle ACM are right triangles. Okay? So for this reason we can implement the function of sinus alpha on both triangles. As you already know, sinus alpha is equals, it applies only on right triangles. So we have two right triangles, so we can implement this function in those two right triangles. So if we focus on triangle AOP, then we can say that sinus alpha equals to the ratio between the side that is in front of angle alpha, that is to say side OP, divided by the hypotenuse of triangle AOP, and the hypotenuse of triangle AOP is actually AP. Okay, the hypotenuse of triangle AOP equals to AP. And now we will also focus on the second right triangle, that is to say on the right triangle ACM. In the right triangle ACM, sinus alpha equals to the ratio between the side that is in front of angle alpha, that is to say side CM, divided by the hypotenuse of right triangle ACM, and the hypotenuse of the right triangle ACM equals to AC. Okay? So in total we got that sinus alpha equals to AP over AP divided by CM over AC. Now we will define AP as X, okay, I will write it here, that AP equals to X according to our definition. So PB will be equal to AB minus AP. Very simple. PB will be equal to AB minus AP. That is actually 90 because AB equals to 90 units and AP equals to X. So in total, PB will be equal to 90 minus X because AB is 90 units and AP equals to X. So PB equals to 90 minus X. Okay, so as you can see from the picture, OP equals to R. So we can write that OP equals to R and AP equals to X according to our definition, and AC, side AC of triangle ABC is given to us in the question. We know that side AC equals to 70 units. Okay, I will write it here that AC equals to 70 units. Okay. Now I will copy again this equation and I will call it equation number 1. So according to equation number 1, OP over AP equals to CM over AC. Okay, I copied this equation here and I called it equation number 1, but here we know that OP equals to R. Here you see that OP equals to R, AP equals to X according to our definition, and PO equals to 7 and AC equals to 70 units. Okay, so I will substitute OP by R, I will substitute AP by X and AC by 70 units. So we will get that OP is R over AP is X equals to CM, we will leave it as it is, CM over AC, that is 70. Okay, here I substituted OP by R, AP by X, CM is left as it is, and AC by 70 units. Now we can multiply both sides of the equation by X. Again, it is allowable to multiply both sides of the equation by X because X is positive number, X equals to AP. So it can never be 0, so it is allowable to multiply both sides of the equation by X. So we get that r divided by x times x equals to r, and cm over 70 times x equals to cm over 70 times x. Here we will divide both sides of the equation by cm. Again, it is allowable because cm is the perpendicular to side AB of the triangle, so it is a positive number, it can never be zero. So we can multiply both sides of the equation, we can divide both sides of the equation by cm, and then we will get that r over cm equals to x over 70. So after we divided both sides of the equation by cm, we got that r divided by cm equals to r divided by cm, and x over 70 times cm divided by cm equals to x over 70, because we have cm both in the numerator and in the denominator, so cm is cancelled. Okay, cm divided by cm equals to 1, so here we got that's cm times x over 70 equals to x over 70, because cm is cancelled. Okay, so this is the first equation. Now we will focus on angle beta, and actually we have two triangles, two right triangles. We'll focus on sinus beta and also on the right triangle PEB. Okay, triangle PEB is a right triangle because angle PEB equals to 90 degrees, and also we'll focus on triangle CMB. Triangle CMB also is a right triangle because angle CMB equals to 90 degrees. Okay, so sinus beta equals, if we focus on triangle PEB, sinus beta is the side that is in front of angle beta, that is to say PE, over the hypotenuse of triangle PEB, that is to say the hypotenuse of triangle PEB is side PB. Okay, the sinus beta is equals to the ratio between the side that is in front of angle beta divided by the hypotenuse of the triangle. So it is PE over PB. Now we'll focus on triangle CMB, the right triangle CMB. It is right triangle because CMB equals to 90 degrees. In triangle CMB, sinus beta equals to the side that is in front of angle beta, that is to say CM, because CM is in front of angle beta. So it is CM divided by the hypotenuse of triangle CMB, and the hypotenuse of triangle CMB equals to CB. Okay? So in total we got that sinus beta equals to PE over PB, that equals to CM over CB. But we will do actually the same process here. We know that PE equals to R. Okay? We know that PE equals to R. The radius of it is the radius of the circle. We also know that PB equals to 90 minus 6 because PB equals to AB minus AP. That is to say AB that is 90 minus AP that is X. So PB equals to 90 minus 6. Okay, PB equals to 90 minus 6. And CB is given to us in the question. CB equals to 50 units. Okay, CB is given us in the question. We know that CB equals to 50 units. Okay, so we know that PE equals to R, PB equals to 90 minus 6, and CB equals to 50 units. Okay, now we can substitute here. First of all, we will copy the equation PE over PB equals to CM over CB, and in this way we'll create the second equation. Okay, I copied this equation to here and created the second equation, that is P over PB equals to CM over CB. Now, as I've already told you, we can substitute PE by R because P equals to R. We can substitute PB by 90 minus 6 because PB equals to 90 minus 6, and we can substitute CB by 50 units because CB equals to 50 units. Okay, so I'll do it now. PE, instead of PE, I write R. Instead of PB, I write 90 minus 6. Equals to CM, we leave CM as it is. And instead of CB, we can write 50 because CB equals to 50 units. Okay, so this is our second equation after we put the data in the equation 2. Okay, P equals to R, PB equals to 90 minus 6, CM, we left CM as it is, and CB equals to 50 units. Okay, now we will multiply both sides of the equation by 90 minus 6. It is allowable because 90 minus 6 is a positive number, it can never be 0. Okay, so we can multiply both sides of the equation by 90 minus 6. We will get that So here we multiplied both sides of the equation by 90 minus 6. So r divided by 90 minus 6 times 90 minus 6 equals to r. Okay, 90 minus 6 is cancelled. And Cm over 50 times 90 minus 6 equals to Cm over 50 times 90 minus 6. Okay, here we divide both sides of the equation by Cm. Again, it is allowable because Cm is the perpendicular to side AB of the triangle, so it can never be 0. Okay, we multiply both sides of the equation by Cm. We will get that we will divide both sides of the equation by Cm. Sorry. So r divided by Cm equals to r divided by Cm, r over Cm, and 90 minus 6 over 50. Okay, we divided both sides of the equation by Cm. So r divided by Cm equals to r divided by Cm, or r over Cm. And 90 minus x times Cm divided by 50 divided by Cm equals to 90 minus 6 over 50, because we have Cm both in the numerator and in the denominator. So Cm is cancelled, because Cm over Cm equals to 1. Okay, so we got the second equation that states that r over Cm equals to 90 minus 6 over 50. Okay, this is the second equation, but actually for the first equation, we got that r over Cm equals to x over 70. Okay, we add the first equation here. We got that r over Cm equals to x over 70. Okay, so this is our, so we have r over Cm from the first equation. For the second equation, that equals to 90 minus 6 over 50, and from the first equation we know that r over Cm equals to x over 70. So now we can create the third equation, that is to say r over Cm equals to r over Cm. So the third equation will be r over Cm equals to r over Cm. So this is the third equation, r over Cm equals to r over Cm. Now we substitute r over Cm on this side of the equation by 90 minus 6 over 50, and we will substitute r over Cm in this side of the equation by x over 70. Okay, so we will get that r over Cm in the first equation, in the second equation, equals to 90 minus x over 50, and r over Cm in the third equation, in the first equation, equals to x over 70. Okay, as I have already told you, we substituted r over Cm by the value of our r over Cm in the second equation, that is to say r over Cm equals to 90 minus 6 over 50, and we substituted RCM in this side of the equation by the value of RCM in the first equation, and RCM in the first equation equals to x over 70. Okay, so now we will multiply both sides of the equation by 50. Okay. So here we multiplied both sides of the equation by 50. So 90 minus 6 divided by 50 times 50 equals to 90 minus 6, and x over 70 times 50 equals to x over 70 times 50. Now here we can divide both sides of the equation by x. Again, it is allowable to divide both sides of the equation by x because x is a positive number. It is equals actually to AP, and x can never be 0. So it is allowable to divide both sides of the equation by x. Okay. We'll get that 90 minus x over x equals to 50 over 70. So here we divided both sides of the equation by x, so 90 minus 6 divided by x equals to 90 minus 6 divided by x, and x times 50 over 70 divided by x divided by x equals to 1. So x is cancelled here, so we left with only 50 over 70. And we know that 50 equals to 5 times 10 and 70 equals to 7 times 10, so we can substitute 50 by 5 times 10 and 70 by 7 times 10. Okay. Fifty equals to 5 times 10 and 70 equals to 7 times 10. Okay, we substituted 50 by 5 times 10 and 70 by 7 times 10. So we have 10 in the numerator and we have also 10 in the denominator, so we can cancel 10, or we can reduce this expression by 10 because we have 10 both in the numerator and in the denominator. Okay, so after we cancel 10, we will get that 90 minus x over x equals to 5 over 7. So after we cancel 10 here, what is left is 5 over 7 equals to 90 minus 6 over x. Now we will multiply both sides of the equation by 7. So after we multiply both sides of the equation by 7, we get that 5 divided by 7 times 7 equals to 5, and 90 minus 6 over x times 7 equals to 7 times 90 minus 6 over x. Here again we can multiply both sides of the equation. It is allowable because x can never be 0. We get that 7 times 19 x. So we multiply both sides of the equation by x, so 5 times x equals to 5x, and 7 times 90 minus x times x divided by x equals to 7 times 90 minus x, because x is cancelled, because we have x both in the numerator and in the denominator, so x over x equals to 1. So x is cancelled there, and what is left is only 7 times 90 minus 6. Okay? X is cancelled. Now here we will open the brackets this side of the equation. We get that 630 minus 7x equals to 5x. So we open the brackets here. 7 times 90 equals to 630, and 7 times minus 6 equals to minus 7x. It's equal to 5x. Here we can add 7x for both sides of the equation. And then that so we added here 7x to both sides of the equation. So 5x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 630. Here we will divide both sides of the equation by 6. We will get that we divided both sides of the equation by 6. 630 divided by 6 equals to 105, and 12x divided by 6 equals to 2x. Okay, but we know that AP equals to x according to our definition. Okay, so the fourth equation will be that AP equals to x according to our definition. Okay, AP equals to x. So if AP equals to x, 2 times AP equals to 2 times 6. This is the fourth equation. Okay, so we have 2 times x equals to 105 from one side, and from the other side, in the fourth equation, we have 2 times 6 equals to 2 times AP, so we can combine those two equations together, and we'll get the fifth equation. So from the third equation, we know that 2 times x equals to 105. But from the fourth equation, we know that 2 times x also equals to 2 times AP. So we can add here that 2 times x also equals to 2 times AP. Okay, here, according to the fourth, according to the third equation, 2 times x equals to 105. But according to the fourth equation, 2 times x also equals to 2 times AP. So we can add in the fifth equation that 2 times x equals to 2 times AP according to the fourth equation. Okay, so at the end we got this equality that 2 times AP equals to 105 units. Okay, according to the fifth equation, 2 times AP equals to 105 units. Okay, so this is actually our final answer to the question. So the answer to the question, the value of the size of 2 times AP, 2 times AP equals to 105 units. Okay, so now I will summarize the lecture. We actually wanted to find the value of 2 times AP, and we have triangle ABC that we know that size AB of this triangle equals to 90 units, side AC of the triangle equals to 70 units, and side CB of triangle ABC equals to 50 units. And we have also a circle. The center of the circle is P, and point P is situated on side AB of the triangle. And we also know that side AC of the triangle is tangent to the circle at point O, and side CB of the side AC of the triangle is tangent to the circle at point O, and side CB of the triangle is tangent to the circle at point E. Okay, actually we connected points P and O together, and actually PO is the radius of the circle, and we also connected points P and E together. PE is also the radius of the circle, so we have here two radiuses of this circle. And we also have a rule that states, rule number 1, in any circle a radius and the tangent to that radius are perpendicular to each other. Okay, so if we have a radius of a circle and we have a tangent to that radius, then the radius and the tangent are perpendicular to each other. That is to say, this angle is 90 degrees and this angle also is 90 degrees. Okay, so according to rule number 1, we can deduce that because of the fact that we have radius and we have also tangent AC to that radius, then the radius is perpendicular to AC, that is the tangent to the radius. So angle POA will be equal to 90 degrees, and also angle POC will be equal to 90 degrees, because in any circle a radius and a tangent to that radius are perpendicular to each other. So therefore this angle is 90 degrees and this angle is also 90 degrees. Okay, and it is exactly correct also for this radius PE, and a tangent CB to that radius. Thus, the radius and tangent CB are perpendicular to each other. That is to say, angle PEC will be equal to 90 degrees, and also angle PEB will be equal to 90 degrees. Why? Because in any circle, a radius and the tangent to that radius are perpendicular to each other. For that reason, this angle is 90 degrees and this angle is also 90 degrees. Okay, so we also defined that angle CAB equals to alpha and angle CBA equals to beta, and we defined that AP will be equal to X, and therefore PB will be equal to AB minus AP. That is to say, PB equals to 90 minus X. And we actually focused on triangle BAC, triangle BAC, and we focus on triangle AOP, that is a right triangle. We know that in this triangle sinus alpha equals to OP over AP, and in triangle ACM, that is also a right triangle, sinus alpha equals to CM over AC. Okay, so in total sinus alpha equals to AP over AP, that equals to CM over AC. But we know that AP equals to X according to our definition, and OP equals to R, and AC equals to 70 units. So we can put the data in this equation, and we'll get that the first equation, that R over CM equals to X over 70. Okay, so then we will do the same thing. So this was the sinus alpha. We'll do the same thing for sinus beta. Sinus beta will focus on triangle PEB. Sinus beta in triangle PEB equals to PE over PB, and sinus beta in triangle CMB equals to CM over CB. Okay, so in total we got that sinus beta equals to PE over PB, that equals to CM over CB. So we can actually copy this equation. Here we copied this equation here, and we created the second equation. But we know that PE equals to R, PB equals to 90 minus 6, and CB equals to 50. So we can put the data in the second equation. So we get that R over 90 minus 6 equals to CM over 50. So, and after, at the end, we got that the second equation, from the second equation we got that R over CM equals to 90 minus 6 over 50. But from the first equation we know that R over Cm equals to x over 70. So from those two equations we created the third equation that states that R over Cm equals to R over Cm. And in the third equation we substituted R over Cm in this side by the value of R over Cm in the second equation, that is to say 90 minus x over 50, and we substituted R over Cm in this side of the equation 3 by the value of R over Cm in the first equation, and the value of R over Cm in the first equation equals to x over 70. Okay, so we got the 90 minus x over 50, the value of R over Cm in the second equation equals to the value of R over Cm in the first equation, that is to say x over 70. Okay, so actually this is only, we have one variable that is x with one equation, so it is very easy to solve it. And at the end we got from the third equation that 2 times x equals to 105. But we know, according to our definition, that AP equals to x, so that is the fourth equation, that AP equals to x, that if AP equals to x, 2 times AP equals to 2 times x. So we can create the fifth equation that states that 2x from one side, according to the third equation, equals to 105. And from the fourth equation, we know that 2x also equals to 2 times AP. So we can add to the fifth equation that 2 times x also equals to 2 times AP. And at the end we got the equality that states that 2 times AP equals to 105 units. So this is our final answer, that 2 times AP equals to 105 units. Okay, so here the size of 2 times AP is 105 units, or the value of 2 times AP is 105 units. Okay, thank you very much.